Many thanks for joining us and welcome to our online chemistry course. In today's lesson, I'll be teaching you the topic organic chemistry. My name is Oderegi Ikodi Esege. The topic is divided into 4 periods. Now, in the first period, which is for this lesson, we'll be looking at the definition of organic chemistry, the importance of organic chemistry, characteristic features of organic compounds, terms in organic chemistry. We'll also look at hydrocarbons, classification of hydrocarbons, and then we'll stop at aliphatic hydrocarbon. Now, let's begin with the very first one, the definition of organic chemistry. Now, organic chemistry can be defined as a branch of chemistry that deals with the study of carbon and its compounds. For the importance of organic chemistry, there are several importance of organic chemistry. In fact, we cannot do without organic chemistry in our day-to-day life. Some of the importance of organic chemistry are: number one, the study of organic chemistry has enabled us to produce dyes to color our fabrics. In this way, we can say that the study of organic chemistry is having a lot of impact on the fabric industry. Another importance is that it has helped us in the production of perfume. You can imagine today that people cannot do without the use of perfumes. Now we owe it to organic chemistry. Another importance is that it has helped us in the production of artificial fibers like nylon and terylene. You go to the market, you buy a product, the product is being packaged in nylon. It is organic chemistry that helps us in such production. Another importance is the production of plastic like polythene. We also have another one, production of insecticide and medicinal drugs. And then also the use of herbal preparation for medicinal purposes is also an example of the use of organic compound present in plants. For the characteristic features of organic compounds, number one, organic compounds are covalent in nature. Now, when we talk about a compound being covalent in nature, is a situation whereby maybe two or more compounds that are joined together. You look at their component elements, the bond between them is not ionic or electrovalent bond. In fact, if you look at their method of formation, you will see that it does not involve the sharing of electrons, unlike ionic compounds, where the metal transfer the electron to the non-metal, and they become, one of them becomes positively charged, the other one becomes negatively charged. Now, in organic compounds being covalent in nature, it does not happen that way. In fact, in this way, the two participating atoms that form the organic compound, they contribute electrons and they share it together. So organic compounds are covalent in nature. Now, because of this reason, they do not form ions, but they form molecules. Another characteristic features of organic compound is that organic compounds that contain polar molecules such as the hydroxyl group, that is the OH, for example, ethanol, they are soluble in water. It is not all substances or compounds that are soluble in water. In fact, sometimes most organic compounds do not dissolve in water, but any of them that contain polar molecules, example, the hydroxyl group, for example, ethanol, must be soluble in water. Another characteristic is that non-polar organic compounds like kerosene, petrol, and paraffin oil are insoluble in water. I think I just made that point earlier. This is because they do not contain a polar molecule. Also, most organic compounds dissolve only in non-polar solvents such as benzene and ether. In our subsequent classes, we'll be looking at benzene and ether. Then another characteristic, organic compounds have low melting and boiling point. This is because the intermolecular bonds or forces that exist between the elements that form the compound is very weak. That is why their melting and boiling points are very, very low. Organic compounds, they are highly flammable and they combust exothermically in sufficient oxygen. Once they do that, they will produce carbon dioxide and water. Examples are petrol, natural gas, and coal. Now, when hydrocarbon burn in sufficient oxygen, the resultant product is normally carbon dioxide and water. You shouldn't forget that. Then another characteristics is organic compounds, they respond slowly to chemical reactions at room temperature, hence there is need for heating. And that will take us to the terminologies in organic chemistry. There are some terminologies that we cannot do without in organic chemistry, and we'll be taking a look at them one after the other. The first one is homologous series. A homologous series can be defined as a family of organic compounds in which the successive individual members differ in composition by a fixed unit, CH2. What do I mean by that definition? That definition means that the members of the homologous series, they differ by one carbon atom and two hydrogen atoms. For example, if I have methane as the first member and I also have ethane as the second member, for instance, the difference between methane, the first member, and ethane, the second member, is one carbon atom and two hydrogen atoms. So that is the definition of a homologous series. Another term is homologues. Now, homologues are the individual members in the family of the organic compounds that differ in composition by a fixed unit, CH2. Like when I was defining the homologous series, I mentioned examples of methane and ethane. These are called homologues. Then another term is an alkyl groups. Alkyl groups are groups derived from the saturated hydrocarbon by the loss of a hydrogen atom. I'm going to give you an illustration now. The molecular formula of methane is CH4. That is one carbon atom bonded with 4 hydrogen atoms. So everywhere you go in the world, methane molecular formula must be 1 carbon atom to 4 hydrogen atoms. Now, a situation whereby the methane reacts with something else and one of the hydrogen is lost, it will form a resultant substance known as an alkyl group. In this way, the methane, which was containing 1 carbon atom and 4 hydrogen atoms, that has lost one of the hydrogen, will now be having 3 hydrogen atoms and then something else. So we can now say that the resultant product formed in this manner is an alkyl group. The next terminology is a functional group. Now, functional groups could be atoms or group of atoms. It could be a radical or even a bond attached to the hydrocarbon, which determines the main chemical properties of the series or family of the organic compounds. When we get to the nomenclature of some of the hydrocarbons like the alkanes, alkenes, and alkynes, and when we start their nomenclature, you will see what a functional group is, what an alkyl group is, and the rest of them. We move on to the next. The next thing on the list we are going to look at is hydrocarbons. Hydrocarbons can be defined as compounds that are composed of 2 elements, carbon and hydrogen, hence their name, hydro and carbon. So in other words, if you're studying hydrocarbons, it means 2 elements are consistent there. We have the hydrogen and also the carbon atom, but that does not mean that sometimes other atoms or elements may not be found, especially when the hydrocarbon has reacted with other elements and atoms. The hydrogen atoms will be replaced by these new atoms they reacted with. Scientists so far have discovered hundreds of different hydrocarbons. That would take us to the classification of hydrocarbons. Now, hydrocarbons are classified into 2 major classes. One, we have aliphatic hydrocarbon, and on the other side we have aromatic hydrocarbon. An example of aromatic hydrocarbon is benzene. Now, the aliphatic hydrocarbon is further classified into 2 classes. We have the acyclic aliphatic hydrocarbon, and the second one is the cyclic aliphatic hydrocarbon. Then the acyclic aliphatic hydrocarbon is further divided into 3 classes. We have the alkanes, we also have the alkenes, and the alkynes. Then the next thing there is the aliphatic hydrocarbon. Let's talk about the aliphatic hydrocarbon. Now, aliphatic hydrocarbons, they are composed of carbon chains. Like you can see something like C-C-C. Now, that is a structure of an aliphatic hydrocarbon composing only carbon chain, and the carbon atoms are connected by a single bond. So those dashes you are seeing, they are known as bond connecting the carbon atoms, and they are single. Then in acyclic compounds, the carbon chains could be straight, like you can see the same structure there, where it is moving straight, just straight in a horizontal manner. If it is not straight, then the compound could be what? Branched. Now look at the second one, the second structure. You can see that it was moving straight, then at a particular point we now have a branch, like starting from the carbon atoms from your right hand side, where we have one carbon, the second carbon, the third one, and the fourth one. There is a branch moving vertically. So in the acyclic aliphatic compounds, the carbon chains could be straight or it could be branched. Then examples of aliphatic acyclic hydrocarbons include alkanes, alkenes, and alkynes. I'll take that again. That examples of aliphatic acyclic hydrocarbons include alkanes, alkenes, and alkynes. Then in cyclic aliphatic hydrocarbon, the N carbon atoms of the acyclic carbon chain join together to form a ring. Now don't get it twisted. There are two things here. We have acyclic compounds and cyclic compounds. Now for the acyclic compounds, I say that the compound could either be in a straight line format, that is just straight. I think I have some illustrations there, just straight, or it could be branched. But in the case of the cyclic aliphatic hydrocarbon, the last carbon atom of the compound will join together to form something like a ring. Now let me show you a structure. Now look at the structure. It was moving straight before, then there is another. In fact, there are three carbon atoms there. For instance, here you can see that the last carbon atom, the one below, is now joining to the other two to form something like a ring structure. So when you see any hydrocarbon that has the form of a ring, it means it belongs to the group of hydrocarbon called the cyclic aliphatic hydrocarbon. This is where we are going to stop for this first period, but remember to feel free to send your questions, your comment, suggestion, or complaint either via WhatsApp, SMS, or phone calls to the phone number 080-6690-6919. Or you can connect with me on Facebook. Just search for Oderegi Ikodi Esige. Or you can follow me on Twitter on the handle @Oderegi. Join me again in the next period, and many thanks.